formula for scale factor? Yesterday we were doing all scale factors. Mo's got the answer. The scale factor, I just put SF because I'm too lazy to write it out. It equals your new image divided by your old image. Whatever you dictate as the new image and the old image is up to you. I always just usually do left or right. Like, I don't know.
I just do it smaller and bigger.
Yeah.
The bigger one is
new. And that makes sense. Like for these word problems, that's probably what I'm going to do because it's easier usually to work with the bigger number. But it is kind of up to you when you want to call new or when you want to call old. Ready, boys? Okay, let's do the first question.
He's a homosexual. What are those towers called again?
Totem pole.
Canoes.
So it says today's going to be all like word problems. When there's a diagram, it's not so bad. Sometimes there's not diagrams. If you read it, it says at a certain time.
Bree, shut up.
Stop talking when I'm talking. Wait, so you gotta stop talking when I'm talking. Thank you. It says at a certain time of day, a person 1.8 meters tall has a shadow of 1.3 meters. At the same time, the shadow of a totem pole is 6 meters long. The sun's rays intersect the ground at an equal angle. How tall is the totem pole to the nearest tenth of a meter? So, with word problems, I would want to underline what they're asking you because sometimes it's not always obvious. This one's right at the end. It says, how tall is the totem pole? That means they're looking for this length right here. I'm going to do it in blue so it stands out a little better. They're asking you for that side of the triangle.
Oh, this is so confusing.
It's not going to be bad. When you're given two triangles with a sun, right? There's a sun creating a shadow. You have similar triangles, meaning that this triangle is just a multiple of this triangle. So if you can find two sides that match, look at the bottoms, those sides both match. And you can figure out what the scale factor was to go from one to the other. You can use that same scale factor to figure out the other side. So for us, our scale factor, we do new divided by old. I like to do big divided by small when it's word problems. So the big side is 6. The small side is 1.3. If I throw that into my calculator, I'll figure out what I'm multiplying by to get my bigger triangle. In this case, 6 divided by 1.3 is 4.615, and that's enough. We just need to do 3 decimals. What this means is that the small triangle times that is how we're getting the big triangle. So if I want to find this blue side, I need to take the equivalent of that blue side and multiply it by that scale factor.
So I'm going to do 1.8 times 4.615.
Exactly. You take this side here, 1.8. You're going to multiply it by that scale factor of 4.615. And that's going to give you the size of that totem pole. Because this triangle is just a smaller version of this triangle. And it's always multiplying by the same scale factor. If you do that 1.8 times that answer, you get 8.3. Because it's in nearest tenth, so 1 decimal. That totem pole is 8.3 meters tall. All these questions work off this idea, right? The smaller triangle times something gets the bigger triangle.
Is there any like trick questions, or is this it?
It can get a little bit trickier. Usually just the pictures get a little trickier. That's honestly what makes it harder. Like if you look at this one, like the picture just like looks harder, right? It's hard to tell which sides match with which sides.
You just got to do the two bases, divide the two bases, and then times the answer by the height.
Yeah. And that'll give you the height of the other one.
Where are the two bases, though? Is the two bases is 73.6.
Yeah, so
28.9.
yeah, when you're looking at a triangle like this where the triangles aren't like side by side, that other one was easy, they're side by side. Try to find the angle that's the same. So notice how they mark these angles right here for you in red. Right? That means whatever's touching these angles would be the matching sides. So these sides right here are matching. I'm going to highlight them in red. This side matches with this side. And whatever's across from that angle, right here, that's across from the matching angle, would be the same as across from the other matching angle. So you have to be able to like find your pair first before you can do the question.
So the blues are the pair.
Blues are a pair, reds are a pair.
And you divide the reds and then times the blue.
Yes. If you times the reds together, that will tell you the scale factor. And then we'll have to talk about whether we multiply or divide, because this one isn't going to be multiply, and we'll talk about why. Scale factor is new divided by old. I like to do big divided by small. So we're doing 73.2 divided by 28.9. That gives me my scale factor between these two triangles of 2,115.48. This means that if I took this small triangle and I multiplied it by that number, it would give me the big triangle. It also works in reverse. So if you have the big triangle and you want to get to the small triangle, you're going to divide by the scale factor. So in this case, I have big triangle divided by the scale factor will give me small triangle.
Do we have to do meters squared again?
Yep, we don't need to worry about our units in this unit. I won't care too much. So in this one, it's 98.3. And then I'm dividing by my scale factor of 2115.48. Oh, sorry. I wrote those in the wrong spot. 211548 divided by 98.3. My bad, I put those in the wrong spot.
So you divided twice.
No, so I figured out the scale factor by dividing these. That's what gave me that 2. That does not add, that's crazy numbers. Just wait, I did a calculation error somewhere. Yeah, I must have hit multiply on my calculator. That's way too big. So if I go 73.2 divided by 28.9, there we go. It's 2.532. I'll get you some in a second. My bad, I hit times instead of divide. This is my scale factor, meaning that the small triangle times that number gives you the big triangle. That's what a scale factor is telling you. If you want to go the other way, so I have the big side and I want to find the small side, then I'm dividing by the scale factor. So for me, I know this big side's 98.3. Because I'm going from big to small, I want to divide by my scale factor of 2.532. So from big side to small side, I divide by the scale factor. You have 98.3 divided by that scale factor, and you get that the width of that thing is 38.8. You're always going one way or the other. If you're going from small to big, I'm multiplying. From big to small, I'm dividing. And that would work on yesterday's stuff too. So if that helps, if you're like, wait, that makes sense, then do that for yesterday's stuff too. And always just do big divided by little. So it can get a little tricky, right? It can't always just be the same process. When you get examples where there's not a picture, draw a picture. Okay? So it says a 6-foot tall tent casts a 10-foot shadow. So if I had a tent that's 6 foot, it creates a shadow because the sun comes down on it like this to create a shadow. And that shadow is 10 feet long. A 6-foot tall tent casts a 10-foot shadow. Beside the tent is a 9-foot tall tree? Tree is 9 foot. How long will the shadow be? When you don't have a picture, draw the picture. Then it's much easier to look at it and work with it. When it comes to these questions, the reading can be hard. This one's not bad, but it can be hard. Underline things that matter. When I read this, it mattered to me, so I made a picture of it. Right? Make sure you underline. All right, to do this question, what's the first thing I'm going to have to calculate? Someone help me out. What's the first thing I'm going to have to calculate on this question? The what? Yeah, the scale factor. The scale factor is the new triangle divided by the old triangle. 9 divided by 6. Which is 1.5. Ooh. Right, gentlemen? Reese? Reese, right? You have to do the scale factor first, right? That's always the first step. What do we do with that scale factor?
So when we have this, you got two triangle, well, you got two angles, you gotta find that, right? Like,
Yeah.
two things.
We know these angles are the same. Yeah.
Once you find the scale factor of one, when you have the measurements of the second one, you can multiply the length. I don't know what length we're trying to find, but you have to multiply the length by the scale.
Yeah, I wasn't asking you, but you nailed it. Yeah. So once you found the scale factor, you have to multiply the scale factor by whatever you have to get the bigger one. Right? Yeah, you're spot on. Calculate scale factor, multiply by the little side to get the big side. So 10 times 1.5 equals 15 feet. Awesome. Yeah, one. It might be. Give me 1 second. I'll come check it out. Go ahead and try the other ones. I'll come check that out after. Scroll this way. Beautiful. This idea of scaling, we did a few days ago with maps and stuff. Remember, we got given scale factors as ratios? We're going to use those scale factors as ratios to solve some of these other word problems. So example 4. Example 4 says San Jose and San Francisco are 9 inches apart on a map.
Yes, Yes, San Jose. I think we're just thinking.
This is San Francisco.
I thought it was San Jose.
It says San Jose and San Francisco.
Oh, well, San Jose is better than San Francisco. No, it's not.
How come?
San Francisco is. San Jose is a better.
You like it? Oh, better, obviously.
San Francisco is the city of love. The city of,
Oh, San Jose is pretty nice
city of
city.
angels. The city that never San Francisco for
That's LA.
LA New York and Paris.
Just like all over the place. Okay. It says San Jose and San Francisco are 9 inches apart on a map.
Actually, they're like 9 inches apart.
On this map, they're actually super close together. Like, you could drive between the two if there's no traffic in like 20 minutes or something. They're super close together. San Jose and San Francisco are 9 inches apart on a map that has a scale of 1 inch to 3 miles.
Don't you have to go through LA though?
No, LA is further south.
Can we just talk about how for the majority of
Map. If the map has a scale of 1 inch equals 13 miles, Reese, we're back on track, we said.
Yes.
If a scale is 1 inch to 13 miles, how far apart are the cities actually? So 1 inch on a map equals 13 miles.
What?
That's on the map, right? 1 inch is 13 miles.
It would be 1.4. Okay, so it's 9 inches apart.
Yeah?
Oh, sorry. Never mind. Sorry, I was right. So 9 times 13.
Yeah.
Yes, okay.
Yeah, because every 1 inch is 13
I
miles.
had brain
So if
fuzz.
you have 9 of them, that's 9 times 13. Would tell you how far apart they are in reality.
I had brain fuzz.
You could do this by creating a scale factor. The scale factor is 13 divided by 1. And then multiply that scale factor by your maps. Or you can just think about it the way that Reese described it and say, okay, if it's 9 inches, multiply that by each one of those is 13 miles, gives you a total of 117. Beautiful. So they're 117 miles apart in reality. That sounds like it's bigger than it actually is. So I feel like those cities are closer than that.